Alright, in this video we are working on 1.1-9 understanding scientific notation, and I'm just gonna get you started on some of this. So question number 1, and again these sometimes tend to be the hardest ones for me. It says, what is scientific notation and why is it used? Okay, scientific notation is a way to write really large numbers and really small numbers. Okay, and then we have the second part of that. It says, why is it used? It's used because it's more efficient. Mathematicians do not like wasting their time. We have lots of symbols for everything, so it's more efficient. Okay, number 2, critique reasoning. Taylor states that 2,800,000 in scientific notation is 2.8 times 10 to the negative 6 because the number has 6 places to the right of 2. Is Taylor's reasoning correct, right? So again, we use to the negative exponent here when it's a number less than 1, right? Is this number less than 1? No, right? So the reasoning is not correct. It should be 2.8. Let's double check. Made sure she moved it 6 times. 1, 2, 3, 4, 5, 6 times 10 to the 6, right? It should be to the positive. Okay. If I looked over here at number 7, how would you write the number displayed in the calculator screen in standard form, right? Standard form means, hey, we got to write it out like we're used to seeing in math class. And so it says 7.6 e to the 12th, right? And this is how sometimes scientific notation appears on calculators. It has that e, right? And that really means like times 10 to the 12th. So really, they're saying, hey, can you take this number and put it in standard form, which means I have to move that decimal place to the right 12 times. So past the 6, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And go back and add my commas there, right? I should have 11 zeros because I had that extra digit of the 6. And that's what that number looks like in standard form. All right, let's go to number 13 here. Express the number. Yep, and I'm going to read that to you in scientific notation. So let's figure out how many times we have to move it. 1, 2, 3, 4, 5. So 5 times we had to move it. But again, it was less than 1, so it's not going to be a positive 5. It's going to be a negative 5.